Hello math students, today we're going to learn about the binomial theorem. And a binomial is just a polynomial with two terms. So this is a real simple one, x plus y. It can be any two terms added or subtracted together. Now when binomials are raised to a power, we have a quick way of expanding them. It's called the binomial theorem. So let's look at what we're talking about. If I raise x plus y to the 0 power, it equals 1. X plus y to the first equals 1x plus 1y. X plus y squared is x squared plus 2xy plus y squared, and so on. So what would happen if we raised x plus y to a really big number? Well, fortunately we have the binomial theorem to help us get the answer to that. So here's what the binomial theorem says. It says in the expansion of x plus y raised to the n power, x plus y to the n is going to equal x to the n plus n x to the n minus 1 times y to the first plus dot dot dot. And then this is the number of n objects taken r at a time. N choose r, blah, 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 blah. Okay, I'm not going to read that out because it's kind of confusing. But basically it boils down to this. The coefficient of x to the n minus r power times y to the r power is n choose r, which works out to n factorial over n minus r factorial r factorial. What's a factorial? Well, 5 factorial means you go 1 times 2 times 3 times 4 times 5. So n factorial would be 1 times 2 times 3 times 4, all the way up to however big n is. Okay? Fortunately, our calculator can do that for us. So let's see how our calculator can do it. If we're going to do 8 choose 3, then that means we're going to have 8 factorial over 5 factorial, 3 factorial. These numbers down here will always add up to the top number. Okay, so we can do factorials on our calculator. I'm going to go to Math and over to PRB, and you can see number 4 is factorial. So let's work out this expression here. 8 Math PRB number 4, 8 factorial, divided by, and I'm going to go parentheses, 5 Math over to PRB number 4 times 3 Math PRB number 4. So that's 3 factorial, and we get 56. Now your calculator can also evaluate combinations directly. So I'm going to go 8. I'm going to go back to the math menu, and this time I'm going to go over to PRB and pick number 3. See that? N choose R. So I hit 3, and I go 3, and we get 56 again. So you can do it either way. Now there's a handy mathematical pattern called Pascal's triangle that helps us find the coefficients of lower powered binomial expansions. Let's go back up here, what we started with. And if we just look at the coefficients of all these expansions, we're going to get 1, 1x, 1y. And then for the x plus y squared, we'll get 1x squared, 2xy, 1y squared. For the cubed, 1x cubed, 3x squared y, 3xy squared, 1y cubed. And for the fourth, 1x to the fourth, 4x cubed y, 6x squared y squared, 4xy cubed, 1y to the fourth. Now do you see the pattern here? Each of these numbers is derived from the two above it added together. So 1 plus 1 gives us 2, 1 plus 2 gives us 3. And so on and so on. 1 plus 3 is 4, 3 plus 3 is 6, and you get the picture, okay? So, if we build Pascal's triangle, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. We can use that to get the coefficients of a binomial expansion pretty quickly. For example, we can use it to expand x plus y to the 5th. Since we're raising it to the 5th power, I'm going to use the row that has 5 in it. So it's going to be 1x to the 5th plus 5x to the 4th y plus 10 x cubed y squared plus 10 x squared y cubed plus 5 x y to the fourth, and then finally 1 y to the fifth. Now, how did I know what the exponents were supposed to do? Well, the exponents of the first term count down 5, 4, 3, 2, 1, 0, while the exponents of the second term count up y to the 0, y to the first, second, third, fourth, and fifth. Well, what happens if you have something besides just plain old x and y in there? For example, 2x minus 3 cubed. Okay, no problem. We'll go to the row with 3's in it, which is right here. And everywhere I would put a plain old x, I'm going to put in 2x. And everywhere I'd put a plain old y, I'm going to put in negative 3. So we're going to have 1 times 2x cubed plus 3 times 2x squared, negative 3 to the first, plus 3 times 2x to the first, negative 3 squared, and then finally negative 3 cubed. And we just work it all out now. So that's 8x cubed. That's going to be a minus, isn't it? Because it's a 3 times 4 times a negative 3. That's going to be negative 12x squared. And then I get negative 9 times 6, positive 9 times 6, which is 54x minus 27. Well, what if I'm only interested in finding one single term in a binomial expansion, not the entire expansion? That's not too hard to do. Let's say we want to find the seventh term of a plus 2b to the 10th. Okay, so it's going to be some coefficient times a raised to some power times 2b raised to another power. Now the question is, what are these exponents going to be for the seventh term? All right, let's go back up to our example where we had the fifth. Okay, the first term had y to the 0. The second term had y to the first, the third term had y squared, the fourth term had y cubed, the fifth term had y to the fourth, and the sixth term had y to the fifth. So the exponent of y is always one less than the number of terms you're looking for. So if I want to find the seventh term, that means that 2b is going to be raised to the sixth power. And these exponents always add up to that main exponent there. So that means the exponent of a has to be to the fourth. And what's our coefficient going to be? Well, remember that the coefficient is the original exponent over these numbers here. Isn't that nice how it works out that way? Okay, so we're going to do 10 choose 6 times a to the fourth times 2b to the sixth. Okay, that's going to work out to 210. A to the fourth, and 2 to the sixth is 64. And of course we have b to the sixth. And 210 times 64 is 13,440. A to the fourth, b to the sixth. And that is the seventh term of a plus 2b raised to the 10th.